Mr. Raghu brings a wealth of experience in technical training, curriculum development, and mentorship, having guided thousands of learners and professionals in their upskilling journey. An alumnus of the Oxford College of Engineering, Bangalore, he has worked with several leading organizations including Alma Beta, Apicelo, and Edureka, where he played key roles in advancing technology education and mentorship. At EGAS, he continues to lead innovation in cloud technologies, machine learning, and DevOps, bridging the gap between industry needs and academic learning. Today, he will be delivering a DevTalk on the topic Agent Collaborations, a dive into Google's A2A protocols. Please join me in warmly welcoming Mr. Raghu Anand to DevHost 2025.
Thank you so much for that warm welcome. I'm going to start the timer. Right. Okay. I think, as you can see, today's topic is agent collaboration, a dive into Google's A2A protocol. Now, let's imagine that you have some chatbot, you have another agent or some kind of a simulator, and these both, they are trying to have some kind of collaboration between them. Now, that is exactly what Google's vision is all about. And to have that kind of collaboration between two different agents or multi-agents, Google has introduced something called as A2A protocol. It's a very new protocol. This was launched just 5-6 months ago. April 2025, they had launched this. And immediately they made it open source, and now this is a part of Linux Foundation. And in the market there are similar protocols as well. You have another protocol called ACP protocol by IBM that also does a similar function to this, but Google's is something very big, and they have this plan to actually come up with something called Agentic Internet. Everything runs by agent, right? That's what their thought is. And let's see how that's going to happen. So yeah, with this, let me give a brief intro about me. Good morning, everyone. It's such a pleasure to be here, and thank you so much for inviting me to this talk. Thanks, Dr. Samath. I've seen him a long time back before one of the event. So my name is Raghu Anand, and I've been in the industry from past 15 years. I have trained more than 7,000 folks in the IT industry. Probably around 2/3 of my. Do we need to speak? Yeah. Okay. Hello. 2/3 of my folks being freshers, and 1/3 of the folks being experienced people. And I have also been very fortunate to have a very interesting thing in my curriculum, in my journey. For every 14 months, my stack changes. I started as a mainframe developer for 14 months. Then it went to VB.NET developer for 14 months. And I don't know why, but the number 14 place, I don't know. I think it really loves me, I believe. Even after joining EG, the first 14 months, it was again new. I was .NET and Angular stack is what I was training. And once again, after 14 months, I've jumped into AI now. So it's artificial intelligence from the past 4 to 5 months. So yeah, this is a few things about me, and I do enjoy cooking, cycling, and gardening as well. That is a great activity to actually de-stress from all the stress that we face currently. Right? So this is about me. A quick heads up. Whatever images that I'm going to show in this PPT is all generated by AI. So I really want to, stress this out that you will find some tweaks, some spelling errors, or even some fingers here and there in those images. So this is something that I really want to share, that AI is good, but you really need to have a human in the loop. That is very, very important, because it's still not that great. Right? And you will see that in the upcoming slides as well, where you will find a lot of images, a lot of mistakes in it. All right? Okay. So what's the agenda? I think we'll start with what AI agent is all about. We'll try to understand AI agent, and we'll see how these agents actually collaborate with tools with the help of MCP. And after that, we're gonna try to understand why we actually need agents to actually collaborate with each other. Why is that so? What is the reason behind that? We're gonna understand that. And finally, we're gonna also see, to have that kind of collaboration, right, we're going to introduce something called A2A protocol, which is agent to agent protocol that has been launched by Google. And post that, we'll also see a few future outcome for this particular protocol, and finally I'll take some Q&A as well at the very end of the session. Right, agents. So I believe that everyone here should be aware, right? You might have seen a lot of news and stuff like that. Everywhere you see it's agents, agents, agents. What exactly is this agents? See, agents are actually intelligent program. They are meant to help us. Now, how they're going to help us? Of course, we have our brain to think, and with the help of our brain, we come up with plan, we come up with some next thing, next steps, right? We do that, right? You prepare a plan. But how does this agent does it? Now, what we do with the agent is that it's just an intelligent program, and we're going to give it some context. What is this context? Context is nothing but information or access to data. Now, we're also going to provide one more thing, right? And that is the access to the outer world. So with the help of this access to the outer world, and with the help of context, easily accessible to the data, this intelligent program can actually plan by itself. It can actually understand what is the goal. With the help of this context, it can actually make decisions. And not only that, it can also take actions on its own. That is exactly what an agent is, an independent unit, right? And of course, so that is what agent is all about. Now, let's jump into a few examples. Now, you might have already been using a lot of agents. How many of you haven't used ChatGPT? Raise your hand. Yeah, I don't see any hand, right? So yeah, ChatGPT is actually an agent. And I think you need to understand something, that ChatGPT has access to other agents as well. It's not a single agent, right? It is going to take help of a lot of different agents. Now, Raghu, why is this? I'm not very sure from how or from when you guys are using ChatGPT. I've been using it from day one. And when I was having this conversation with ChatGPT, I used to get an error. There was this message: the model has been trained only till so and so date, right? So when I was trying to search something which is happening currently, it used to not help me. Okay, it never gave me any answers. It used to tell I can't do it because I don't have access to that data. So this was the problems that agents faced at the very beginning. And what actually they did was, of course, I'll come to that point as well in the next thing. We have something called MCP protocols, which is very amazing, by the way. So what they did was, they actually came out with different agents. Like one example is, you can see the browser agent here. Now what the browser agent does is, it actually checks the internet. It accesses the internet for real-time information, and it feeds the real-time information to ChatGPT. Getting my point? And then ChatGPT will actually give you a response. And if you see, there is another agent as well called as retrieval agent. As the name itself says, it's actually used to access files and stuff like that. If you see now, you can actually download some file, you can upload images, you can upload a PDF into ChatGPT. Have you come across this? This is all because of the retrieval agent, which helps us to do that. And there is another agent as well, which is the MCP agent. Amazing stuff, right? What this MCP agent does is, it's going to help ChatGPT to connect with the existing APIs. It's going to help connect with the existing database. It's going to help connect with the existing modules or systems or files, right? So that's how these things are. So yeah, and of course there are other agents as well, like you can see code interpreter for coding, debugging, bug fixing and stuff like that. You also have the image understanding agent. You can see the spelling mistake, right? So that's how AI is. It's still not up to the standard. So yeah, upload image, download image, getting an image, right? All those things works in that image understanding agent. I think next, let's see another example of how it works with GitHub Copilot as well. Most usually tool by organizations, IT industries actually use this a lot. 99.99% of all the organizations actually use this, so it's very important. So even in GitHub Copilot, by the way, I think you are already aware what GitHub Copilot is. It's going to help you write code and fix bugs and stuff like that. It's a developer assistant agent is what we would like to call it as. And even in GitHub Copilot, there are multiple agents, and one important agent is the Copilot CLI agent. Now what it does is it's going to automatically write shell commands in the terminal. Because I hope everybody has used Git. So you might be aware that you need to put the commands, right, pull, push, clone, all those commands are there. They are all used in the terminal, right? And now the agent will do that on behalf of you. And which is the agent that is responsible? Copilot CLI agent, okay? And Copilot Docs agent as well. Documentation is something that is very, very important for IT industry. Though you are a developer or though no matter what role you're going to land, you need to do some kind of documentations. That will be a part and parcel of your IT professional, right? And here in GitHub Copilot also we have something called as Docs agent that's going to really help you and create documents and stuff like that. And you also have other agents like Copilot pull request agent, Copilot chat, a chat bot where you can chat and get some answers to your whatever tasks you would like to have. Okay, yeah. So we have seen what agent is. We have seen the different agents that is used by the existing agents. Now let's see how actually this agent leverages these tools. So there is something called MCP, Model Context Protocol. As the name itself suggests, it's a protocol. What is a protocol? It's a means for communication. It's a standard for communication, right? And that's what MCP is all about. It is just a means of communication. Now, hey Raghu, with whom the agent needs to communicate? I already gave you the example, the browser agent. ChatGPT uses the browser agent, right? And it needs the real-time access to it. Or it may require some image, it may have to pull some images and all those stuffs. Or it may need some data, it may require access to some APIs, the tools. And that's exactly what MCP is going to help you do it, and in a safe and secure manner. Okay. And of course, one more important point is that you can't directly poke the agent. Agent doesn't say, you know what, please come and make your request. No, there has to be a standard set, right? And that standard is actually provided by MCP. Okay. Now, let's look at how actually it works. This is the architecture that I borrowed from IBM's website. Now, as you can see here, let's assume that you are the user, and then you're going to use a protocol called as AGUI protocol. It's called as Agent User Interface. So using this protocol, the user can actually have some kind of interaction with the agent. And then the agent, with the help of MCP, it can actually access APIs, files and database. Hey Raghu, can't the agent access them directly? Can they do that? Can an agent access a database or API directly without MCP? Not possible. The reason is very simple. Agent is very new, but APIs, database are very old thing, right? So they already had a previous standard, and agent has some new standard. And I mean, it's simple like this. If I try to send a WhatsApp message to, let's say, your friend here, if she doesn't have WhatsApp, will she be able to receive the message? Somehow we need to have the same standard, right? I should install WhatsApp, even she should have access to WhatsApp. Then only we can communicate with each other, right? Same story. You need to have some kind of bridge, right? Because API, it follows a different format. Database has a different format. So how do you bring that to a same stage? And that bridge is what is MCP is all about. Okay? Yeah, and one more thing. So as you can see, many capabilities are there. This is just some examples I have given you, APIs, files, databases. But you can have a lot of capabilities like search, query, and all those stuffs. So how agents collaborate with tools? Just a few examples. Let's say that you have some file MCP server, right? You are trying to access a file from a ChatGPT or something like that. And now what ChatGPT does is it's going to leverage MCP and it's going to access the file MCP server. And in this particular MCP, through the MCP, it can access these three different options: search, open file, delete. So these options would be made available to ChatGPT with the help of MCP. You can't directly delete something. You can't directly update something. I think even one of the new feature that you might have seen is Zomato is trying to test a feature where you can book a delivery using ChatGPT. I hope you might have come across that news. Now what Zomato is trying to do is, Zomato is not giving a direct access to ChatGPT to actually do changes in Zomato's database or Zomato's booking system. And what they have done is they have come up with the MCP. So this MCP helps a secure channel. It creates a secure channel between the ChatGPT and the Zomato's existing booking system. And the user can directly go ahead and say, hey, please book me so and so from this restaurant. That's it, done. And ChatGPT with the help of this MCP will actually place an order on behalf of you. Right? This is a real scenario that is actually happening. And it's happening in a lot of places. You have something called Figma MCP for design systems, etc. And then another example is CRM, which is again customer relationship management is what we would say. And once again, we also have some MCPs for that as well. You can actually directly fetch the customer record, do some updation, and then you can write that in the database as well. Okay, these are few examples of where we could see those the role of MCPs. So you might have seen what agent is, and you already saw what MCP is. Now the big question is, do we really need agents to collaborate with each other? Now this is a big question, and I'll come back with a question: did we really need GitHub in the first place? Why we required GitHub in the first place? To have easy collaboration, to remove repetitions. Yes or no? Same stuff. We really require agents to collaborate. Why? Think about it. One of your friend introduces an agent, and another friend also introduces an agent, A and B. Now, A and B are two different agents, but if you look at these agents, they do perform 50 to 60% of the tasks are similar in nature. Okay, and project A or your friend's project A, right? It has access to better context. It has access to better data. Whereas the second project doesn't have access to data. So it doesn't know what the thing is. So what I'm trying to tell you is that, guys, right now what has happened is people have realized that even when you create agents, there's a lot of repetitions that is happening. And we want to actually bridge that. We do not want these repetitions because it's already done. Why should we reinvent the wheel? We can just go ahead and leverage what is already available. So that was the thought process behind it. And look at this, we have many highly specialized agents, right? In our company itself, we have a HR bot, we have something called Shasha, which is for customer support bot, and we have multiple different agents we have within our company. And what I myself see is that all these agents have some kind of similarity. They have, right? So we want to eliminate them in the coming days as well. And remember this, each agent actually works independently. So the HR chatbot doesn't understand what Shasha chatbot is doing. They don't have that connectivity between them, right? They don't have that idea as well. So it's often missing some kind of tasks, or it's missing some kind of context between them. And what this does is it's going to create a isolated intelligence, right? So project A will have some kind of intelligence and project B will have some kind of intelligence. It's just like, you might see in your college or in your class as well that, your friend is better at reading, whereas you can see another friend is better at communicating, right? So that's how different agents have different power, and we just want to bring them together into a single unit. So let's take this example, enterprise workflow, right? Let's assume I'm going to get a promotion very soon and the HR team, wants to promote me, and they are trying to access some data about me. And now the problem here is the L&D agent is a different agent. The HR wants to know, have I completed all the mandatory trainings, right? But unfortunately the L&D agent is different. So now you need some kind of manual work involved here, right? You need someone to go ahead, talk with the L&D agent, download the reports that, okay, what Raghu has done, has he completed all the mandatory trainings or not? And then you need to come back and feed it into the HR agent. And then the HR agent will take a call, okay, yes, he should be promoted or no. Even if HR agent takes a call, let's say, okay, he has completed all the mandatory trainings, so let's put him for promotion. Then the finance agent comes into the picture, says, hey, you know what, we are out of budget, right? So that's what, right? And again, there also we get stuck. So as you can see, you have different agents, but there is always a gap, and we want to address that gap. And same thing goes for the second example as well. You're planning to book a travel or some travel itinerary, and you're trying to search for flights, you're trying to search for some place, and you're also trying to build an itinerary, right? So it's a 3 different tasks you need to do. You can't do it parallelly. You have to do it serially, one by one, right? And it often comes back to the same place as well. So we want to connect that. And how do we connect it? Well, it's Google's A2A protocol. That is the answer. So it is this particular protocol which is going to help us or bring collaboration between agents. So let me reintroduce Google's agent-to-agent protocol. As I already said, it was released by Google April 2025. It's just been 6 months. And what it does is it actually enables a direct communication with different AI agents. And the main reason why it was created was it also addresses a gap that MCP couldn't do. Look, MCP is something that is within your grasp. Let's say person A, he or she wants to access, or they have some kind of information with them. Okay, now that power is because of MCP. and now they want to access something else from, let's say, their teacher, and how we can bridge that with the help of A2A protocol. Okay, that's how A2A protocol works. And they both are compatible. You can use MCP and you can use A2A together. And of course, how does this work? Well, I'll show you the architecture behind A2A protocol as well. You will realize that there are three different sections. One is discover, communicate, as well as collaborate securely. I'll show you that architecture in the next coming slide. And remember, everything has been envisioned by Google, and they want to create a agentic internet. So basically they are saying the entire internet will run by agents, right? So that's what their vision is. Let's see how that is done. So this is the three different layers that I was talking about. One thing about Google is they always build product which scales. They don't come up with some small product which doesn't scale. They always come up with something which scales. So in the market, you already have something called HTTP, JSON RPC, which is used to what? Why it is used? Communication, request response, client sender, right? So it exactly uses the same concept. The A2A protocol is based on the same communication channel. It also has something called SSE, server, sent. Anyone? Okay. Sorry? Okay. So this is something, a layer which helps in streaming. You don't have to wait till the entire response is generated. You come, you make a request, you leave. And this SSE will make sure that it keeps on beaming you the output or the response slowly one by one. It's a streaming services. Okay. Then you have something called as authentication and encryption as well, which is again by default with the help of HTTPS. It gets authenticated and it has all the security measures. Then you also have something called as agent discovery, just like a visiting card or ID card, or like whatever ID card you are wearing. It actually shows who you are, right? It helps people discover who you are. Am I right? Same story. You have something called agent card, which whoever is creating the agent has to create that card. Okay. So with the help of that agent card, the other agents can actually discover what this agent is all about. And yeah, of course, you have the other things as well. Context handling. What is the capacity of this agent? What kind of operations does this agent helps us to do? Can it let me query? Can it let me download a file? Can it let me edit? Getting my point? So those kind of things you get to know there. And of course, you are able to also access through API as well. That is another important point about it. Yeah, I think this is about how the protocol is. 5 major points or very important structure. The principle that was used by Google to build this, built on web standards, secure by default, modality agnostic. It works on all the data formats that is available, right? So even if tomorrow some new format comes, it will still support. Then you have something called long running task, because you cannot wait for the output now, but you need to wait for the output for every interval, and that's when the streaming updates comes with the help of SSE. Then you also have open and interoperable, right? So it helps in that process also. It's open source now, so anybody can use it. Okay. So how it works? A quick snapshot. So you have an agent client, you have a server client or a server agent. And remember team, I would like to bring one more point, is that any agent can act as a client or a server. It's not that you're going to have different agents for server and different agents for client. No. a same agent can act as both server and client. Okay, so in this case you have this A, B. Now what happens is A discovers B with the help of A2A protocol. Once the discovery is done, then the agent A will do a handshake. Handshake is nothing but making some communication securely and safely. And post that, it gets authenticated. Once it is authenticated, now it's ready for receiving the task. Okay, and that's when client A will start to send a request, and then client B will give a response immediately, or with the help of streaming services, it can give you at regular intervals. So let's go to the core part, like, hey, what is that? What is that agent card? What is the task? How this request response happens? What is this? So I'm trying to make it open there. It's a high level. I'm trying to go one more level down. So as you can see, the agent client actually sends or checks the agent client. It's a card, agent card. And what this agent card does is, it's like, as I said, it's a ID which has all the data in it, like what is the operations that we can perform, what is the capability, what is the endpoint through which I can access this or that. And then it also has something called as a task, like what is the task that I want to do, right? I can put it there. And then you have the message or the artifact as well, which is like what is the structure you want the response to be in. Okay, so either you get a single response or you get a response in multiple parts. Okay, so let's move on to this simple example. So as you can see, I'm a user, and what I'm trying to do is I want to plan a 3 days business trip to Singapore from November 25 to 28 under $1,500. Unfortunately, ChatGPT missed the dollar symbol even though I gave a great prompt. So what is happening here is the user pushes this prompt to the agent, to travel planner agent. It's a name. You can assume this as ChatGPT. And now what this agent does is it analyzes the prompt and it understands that it has 3 different things that it needs to perform. One is it's a 3-day itinerary it has to come up with, and then it has to even book flight tickets for me to Singapore, and then it also needs to book me accommodation under $1,500. So three different things which it doesn't have access to, right? So what it does, it's going to ask help from the other agents through the A2A protocol. So it's going to say, hey, hotel agent, can you find hotels for 3 days in this location where the budget is less than 1,500. Same thing with flight, same thing with itinerary. And now what happens is that these agents will actually have access to the, let's say this is a hotel agent, right? So it's going to have access to the API. Through API, it can connect to Make My Trip, right? And it can fetch the data. Getting my point? It's as simple as that. And let's say for this, again, API, this the MCP, it comes and it again accesses some website, Expedia or something that, where it can book the flight tickets. And again, the itinerary also, with the help of APIs, it can access another website to access and come up with different itineraries. Okay, and then all the data is again given back to the travel planner agent. Now this agent collaborates everything together, and then it puts an answer to the user saying that, hey, look, this is what it is. This is the plan for 3 days. This is the hotels that we have shortlisted, and this is what the budget is. So that's exactly how this works. So I would like to also have another example, career advisor example. So let's say that you are trying to find a job and you want to apply based on the profile that you have. So this is the prompt: find and apply to jobs that match my profile. Software engineer, remote job, and the salary expectation is less than $120K dollars. Have I given my profile here? I'm just saying match my profile. Okay, please look into that very carefully. So now again what it does, again the career agent, it decides, it breaks down. It needs to search job sites for job openings. It has to prepare a resume based on the job description, and then it has to send an email to that company with my updated resume. So there are like 3 to 4 different things that needs to be worked on. And again what it does, it triggers all these 3 different agents, and again with the help of MCPs it accesses it. Now since I have said match my profile and I haven't given where my profile is, so what the resume builder will do is it will check for previous histories. It will check for previous histories, and based on the previous histories it will try to find out what my profile is. It will build a profile on itself, and then it's going to populate that in the job description, and then it's going to, once all those resumes are created, then with the help of this application agent it's going to send email to all the 20 or 30 companies that it has shortlisted. Okay, so this is how it actually works, guys. And as you can see, with the help of A2A protocol you can have multiple agents combined and just one single prompt. You don't have to go to all these different agents and give different prompts. So instead of giving 3-4 prompts, you have come back to give only one prompt. Okay, that's the power of A2A. So now a small activity. So I want you to think about a prompt which would use this architecture. Just come up with a prompt. So this prompt should trigger how many agents? 2 agents. Anyone? Yeah.
So I can think of a music generation agent, which would ask the first agent to synthesize a tune, synthesize a melody, and ask the second agent to try to come up with lyrics that fit in well with the melody that was generated by the first agent.
Anyone else? All right. Thanks for that. I think that's an amazing example or an amazing prompt where he's trying to come up with the tune as well as the lyrics, and it matches both and it provides you that. Amazing. Come up with a prompt which would work on this kind of architecture. Anyone? So you have agent A. Yeah. Anyone? Anyhow, I'm not going to give the answer. So I'm just trying to explain. So you have agent A, which triggers 2 different agents with the help of A2A protocol. But unfortunately, this agent as well requires help of another agent. So it's going to trigger A2A protocol and it's going to call that as well. So guys, I want you to think there is a huge meaning behind this particular architecture. As you can see, we are moving towards a very closed agentic world, where everything could be done by agents. Okay, so take it as a homework or something like that. Think about the prompt. Maybe if you want, you could take a photo pic of this and you can give it a shot at your home. I'll wait for 10-15 seconds, then we'll move on. Can I move on? All right. So we are here. The last slide. Future of A2A. Now, as I told you at the very beginning, we also have another protocol called ACP protocol by IBM, right? Then the question may pop up, hey, there are multiple protocols and which one should I use? So this slide answers that. So you need to understand that the A2A has an amazing future because it's actually led by Google with the help of 50 different launch partners. So all the big names in the industry have come together. They have worked with Google to actually put out this particular standard. That means this standard is already widely used by these companies. Okay, and since Google has used, Google builds products which always scales, right? So you can actually integrate this with the existing AI frameworks and the cloud subsystems as well. So it's super easy. And Google has built that A2A protocol with the vision that in the future it is going to be Agentic Internet. So still many things are going to come slowly. And agents will negotiate, coordinate, co-create across networks. So meaning in the coming days, you just give a prompt and ChatGPT will create an agent. Getting my point? In the diagrams I showed you there is already an application agent and all those agents. What if that agent doesn't exist, which is required? ChatGPT will create. So that's how Agentic Internet is all about. So Google's vision is very high. So we're going to see a lot of automation in the coming days. But yeah, the key takeaway, I think the A2A enables collaborative intelligence across agents that can truly work together, right? So I think with this, thank you so much. I would like to take questions. We still have 3.5 minutes left. Any questions? I was expecting some questions about, since you are from college, or how the placement stuff, that there's any questions? No questions? Okay, maybe I'll pick one question from my side because I hear this a lot on my LinkedIn profile. What is going to happen with the jobs? Right? So, because even few of the students messaged me on LinkedIn as well saying that, hey Raghu, what will happen to the job? Are there any opening? Are there any hiring going on in the company? So I think, see, you need to understand something very important, that change is constant. And we humans, we have been doing it from a very long time. We always try to invent something that helps us. We invented that, what is that, smelting process, or why? We needed some better utensils, right? So it's the same thing, we are inventors. We keep on inventing. We always come up with something new. Initially we used to think or do maths using fingers or something like that. Then we had calculators, then we had machines, and now the things, right? So we are innovators. And I think that's exactly what has happened. Okay, so we have innovated something on agents or AI. So what is going to happen? Same thing, whatever happened during those inventions. The people who were working with the old traditional method, they lose the jobs, but new jobs will be created on the new thing, right? So that is exactly what is going to happen as well. So maybe the traditional approach may not work anymore. You will not be able to find jobs, the traditional profiles. You may find jobs in the new stuff, something related to AI, right? It's a cycle. You can just look at the history, right? So history repeats itself again. But of course, yes, I understand that now we have this internet and all these things, and everybody is able to access the information very easily. So everything is getting spread faster, and people may feel a bit troubled by it. But as I said, new jobs will surely pop up. And as I already showed you, right, there were a lot of images with mistakes, correct? So AI can't do everything by itself. It really needs a human in the loop. Okay, so we need someone who can understand the entire picture end to end. That's what the future is going to be, right? You should be able to be a developer, you should act as a tester, you should act as a product manager, right? You need to be able to manage the end-to-end life cycle, because we want those kind of resources going forward, because AI is going to generate everything, right? So we need someone who can understand everything and review it. Getting my point? Because we can't, if something goes wrong, we cannot blame AI. We will blame the person who reviews it. So we need someone to blame, right? So we will hire. I hope I answered it, right? At least for blaming, we need someone, right? All right. So with that, thank you so much. Thanks a lot.
Thank you to Mr. Raghu Anand for an insightful session on multiple AI agents, MCP and its servers, and the A2A protocol. The real-life examples made the concepts clear and showed how AI systems collaborate in practice. Now, as a token of appreciation, I would now like to invite Mr. Shaman sir to present a memento to Mr. Raghu Anand.